Hello everyone and welcome to this presentation on unit testing. My name is Lars Asplund and I'm working with Synective Labs. To describe what unit testing is and why we should use it, I'm going to apply some basic control theory on the VHDL development process. But to more easily explain those principles, I'm going to start with a completely different example. So here I have a self-driving toy car which takes a target destination, feed that into a built-in software controller which generates control to the DC motor of the car as well as the steering. The result is an output route that hopefully leads to the destination. In a system like this, we will have uncertainties. For example, the surface we're driving on may be slippery. And control theory will tell us that if we have uncertainties, we need a feedback in order to control that system successfully. So we add the feedback to the output by installing a navigation system that can measure the route. Now it's important that we add the feedback to the output and not to some signal within the system, because it is at the output where we can see and compensate for all the uncertainties in the system. However, the navigation system itself may also have uncertainties. And one way to reduce or remove that problem is to do sensor fusion between different types of sensors. Each sensor or navigation system will have different type of uncertainties, and they can compensate for each other's deficiencies. If we manage to do this and remove the sensor noise in the feedback loop, we will have a controller that can continuously compensate for the uncertainties within the system and successfully lead us to the target destination. Now, if we apply this to the VHDL development process, we see that we also have a controller. The project members that take a problem description from the customer and use that to control the development process where we do requirement, design, and implementation work. The output of this process is a number of features that together build a solution to the problem we have. We also have uncertainties, for example, incomplete requirements and bugs in our implementation. So we also need feedback in order to control this successfully. So we do reviews and we do testing of code. Now remember, the best feedback we get from the output of the process. So the output in this case is VHDL code. So the best feedback we get from code review and from testing that code. Now, there are uncertainties in our own testing because we may not fully understand the problem that we're trying to solve. So it's important to also deliver to the customer who knows the problem and let them test as well. So in a way, we're doing sensor fusion between our testing and their testing. If you remember the first car animation, I did take back-to-back samples on my feedback loop. Now, in reality, it might be that after I take a sample at the green dot, it is some processing delay before I can apply new control at the blue dot, and then I take a sample again. This means that I get a lower sampling frequency and a delayed response. And both these things are bad for the performance of the feedback loop, as you can see in this simulation. So the implications on the VHDL development process is that if we're going to combine testing and code review with a high frequency, we need to split our system into small bits and pieces and develop those in iterations. So we test and review every small piece, which we call a unit in code, but we also need to integrate that with our previous results, do regression testing, and make sure that everything still works. That integrated piece of code can also be delivered to the customer so they can do their testing. When I'm talking frequent, I'm talking about testing at a daily basis, because we want to compensate for the uncertainties we have, and uncertainties like bugs enter the system on a daily basis. Now, it may not be possible to deliver to the customer on a daily basis. We may not have hardware when we start a project, we may have long FPGA build times, or we may be developing for an ASIC. Code review on a daily basis can also be hard unless we do pair programming. However, it is possible for us as developers to test on a daily basis, both our own unit and do integration testing, if we have very good support. And with all that testing at that frequency, good support means automation. And that is the primary purpose of the unit testing framework, to provide us support for automation. So far, I've been motivating the use of unit testing with control theory, but there's also research in this area. It shows that projects working more with iterations are more successful than those that don't, and that smaller iterations are to prefer in order to increase the success rate. So in summary, test, code review, and deliveries give the highest quality feedback, and we need early and frequent feedback in order to manage our project in the best way. This is only possible if we develop in small iterations, and small iterations are only possible with automated unit testing. If you think this sounds interesting, you can go ahead and have a look at the open source unit testing framework for VHDL, VUnit, which is available on GitHub. There you will also find more examples and more tutorials. Thank you for listening.